Have you ever spent hours trying to find the broken bulb on a strand of Christmas lights before you can put them up on the tree? It's because they're wired in a series circuit, so if one's broken, none of them work. So today we're going to talk about electrical circuits. So circuits are what is used to transport electricity to an object. We measure current, voltage, and resistance when we're talking about electric circuits. We measure current using an ammeter in amps, voltage using a voltmeter in volts, and resistance using ohms. There are two general types of circuits, which is series, where there's only one path for electricity to flow, and parallel, where there is more than one path that electricity can flow through. So the top left picture is a series circuit. So there's three light bulbs connected, but if one of the light bulbs broke and wasn't able to connect to the circuit, all three light bulbs would go out. And then the one on the bottom is a parallel circuit because there's more than one path for electricity to flow through. So if one of the light bulbs went out, the other light bulb would be able to remain on. And then lastly, that's a picture of a multimeter that we can use to measure volts or amps. So electric fields exist around any charged objects and between two different charged objects. Conductors permit the movement of electrons, so wire is a conductor. If you have electric conductors in contact with oppositely charged poles of a battery, electrons are going to flow from the negative pole to the positive pole. And this is called an electric current. So current is the amount of electrical charge moving past the point at a specific time, and we measure current in amps. So any continuous set of conductors or network of conductors is called a circuit. So wires, batteries, switches, motors, lights can all be part of a circuit. So a resistor is anything that reduces the current flow in a circuit. So some resistors create light, like light bulbs. Other resistors can create sound. Some resistors create heat, like in your electric stove element. And this regulates the speed you can also regulate the speed of a motor to ensure that safe limits are maintained. The formula for resistance is voltage divided by current, and this is in your data booklet. So if a car uses a current of 5 amps from a car's 12-volt battery source, there's what we can find out the resistance that the headlight when it's on. But first, just a quick question. Is this a DC or AC energy source? Now, if you remember that a DC source comes from a battery, then that would be the source of the electric current that's powering these headlights. So if we go through to find resistance, which is equal to voltage divided by current. So we can put in the values that we know. So 12.0 volts divided by 5.0 amps. We get a total resistance of 2.4 ohms. And then this formula can be rearranged to find either current or voltage, depending on the information you're given in your question. So when we're looking at resistance, there are some things that will affect it. So the bigger the cross-section of a wire is or another component, the less resistance there is, because the more easily electrons can flow through that space. There's less friction up against the edges. The longer the conductor there is, the greater the resistance, because again, the longer the kind of channel is that those electrons have to flow along. When temperature can also affect resistance. So resistance increases as temperature increases. So to measure resistance, we are going to use our multimeter and set our dial to ohm meter. So often it'll be OHM or it'll be the symbol for ohms. We're going to attach the leads. The red is positive and the black is negative. And we're going to switch the power off on the circuit. Then we're going to connect the meter and measure the value. So when we're drawing circuits, there's different schematic diagrams that we can use. And again, these are going to be in your data booklet. And there can be a cell, which is just one energy source, a battery, a series of energy sources, a switch so it can indicate if a line is open or closed, voltmeter, ammeter, resistor, variable resistor, and lamp. So when drawing your circuit, these are many common icons that you can use. So in a series circuit where there's only one direction for electricity to flow, we calculate total voltage by just adding up all the different voltages of the cells together. And to calculate total resistance, we just simply add the resistance of all the components that could resist the flow of electricity in our circuit together. When we have a parallel circuit, our batteries tend to last longer. And because the components are connected with more than one path for the electrons to flow, we can turn on or off individual components of the circuit. Current is increased as more paths are added, and resistance is halved as more paths are added. To calculate the voltage of a parallel circuit, we're going to add the voltage. Each path has the same voltage that goes through it. And to determine the total resistance of a circuit, it's the inverse of the total resistance is equal to the inverse of each individual resistance component. So I just want to point out that to calculate our resistance total, we then have to take 1 over that total resistance. So here's an image on the left of a series circuit connected with a single cell battery, and on the right, a parallel circuit with a switch and a single cell battery. So Ohm's law gives us the formula V equals IR, or voltage is equal to current multiplied by resistance. And again, this equation can be rearranged to find both current and resistance. So if we have two identical resistors connected in parallel as shown, what is the current through ammeter 1 and ammeter 2? So if we have the total current that's going through ammeter 1, it's going to match the total current going through this ammeter here. So ammeter 1 has a total current of 3.0 amps. Now ammeter 2, in this location, to match the total current of 3 amps, this ammeter has a current of 2. So going through ammeter 2 is going to be a current of 1.0 amps. Okay, now we're going to look at a series circuit. So 4 resistors are connected in series with a 12-volt battery. 2 of the resistors are 10 and the other 2 are 15. So we're going to draw a diagram of the circuit. So I'm going to draw my battery here. And then I have a resistor, another resistor, a third resistor, and a fourth resistor. So here I might have a 15 ohm, a 10 ohm resistor, another 10 ohm resistor, and a 15 ohm resistor. So what's the circuit's equivalent or effective resistance? So I'm going to add them all total. So my total resistance is equal to R1 plus R2 plus R3 plus R4. So this is equal to 15 plus 10 plus 10 plus 15, which gives us a total of 50 ohms. Okay, now we want to calculate the current through the circuit. So current, if I look on my formula sheet, I'm going to use my current is equal to V over R, which is going to be equal to a total voltage of 12 divided by 50. 12 volts divided by 50 ohms. And this gives us a total current of 0.24 amps. So we can have combined circuits that have series and parallel being used together. So kitchen devices are connected in parallel where we can turn off the blender but not the fridge. And each device in it has a series circuit to switch it on or off. So if we open the switch, that device is now not able to be used. So there's not 2 paths of electricity to get through once that device has been plugged in. Drawing series and parallel circuits is a great way to visualize a written question, and I hope you enjoyed the lesson today.